Good morning, afternoon, or evening. How y'all doing today? Welcome back to Moro's Math Corner. Today we're going to be learning how to graph and find solutions and different information from systems of inequalities. In order to solve systems of inequalities, I want you to remember that you just simply have to graph and shade each inequality individually. Okay, let's do one at a time. And then the area of the system which has overlapping sets are the solutions of the systems of inequalities. And if you shade it the way I'm going to teach you today, we're going to create a little checkerboard in the actual overlapping area, which makes it very easy to identify the solutions. So let's get right to it. All right, so you have to know how to graph linear equations in order to solve linear systems. So we're going to start here with this guy. I'm going to go ahead and color code things. I'm going to use blue for the first one. My y-intercept is -5. And my slope is 3. So I'm going to go up 3, 1 to the right, up 3, 1 to the right, up 3, 1 to the right, down 3, 1 to the left. And that's going to be a solid line because it is greater than or equal to. If it's greater than or equal to or less than or equal to, it's solid. If it's greater than or less than, it is dashed. So this is greater than or equal to, and a little trick I always like to use is identify the y-intercept and then read the shading from there. If y is going to be greater than or equal to this function and my y-intercept is -5, greater than that value is going to be above it. So I'm going to shade above. And then we'll go ahead and change colors and go to purple here for the second inequality. And with that y-intercept is 5. And my slope here is down 1, 2, 1 to the right, down 1, 2, 1 to the right, down 1, 2, 1 to the right. Let's go backwards, up 1, 2, 1 to the left. This is a solid line, and it is less than or equal to. So if we use that same kind of logic for the first one, my y-intercept is 5, but I'm looking for y values that are less than, so I'm going to shade below it. And you can stop there, but go ahead and don't stop for a second and notice that this shaded area here has a nice, wonderful overlap. This is my shaded area. These are my solutions. And there you have it. So now you can answer questions about the solutions looking at the actual highlighted solution set. All right, so that should be pretty easy. Let's continue here. In order to solve any system of inequality, you're going to have to, first of all, solve for y, put it into slope-intercept form. So let's go ahead and subtract 2x to both sides and then divide by a -1. And that is going to give me y is now less than or equal to 2x plus 3. Please note that since I had to divide by a negative, I flipped the inequality. So we'll go ahead and stay in black here. So y-intercept is 3. My slope is up 1, 2, 1 to the right, up 1, 2, 1 to the right, down 2, 1 to the left, down 2, 1 to the left. It's going to be a solid line, and it is less than, so I'm going to shade below the y-intercept. And then here in blue, my y-intercept is 1. My slope is down 1 over 1, 2, down 1 over 1, 2, down 1 over 1, 2, backwards, up 1 to the left, up 1 to the left. And that is also going to be a solid line because it is greater than or equal to, and it's greater than or equal to, so I'm going to shade above the y-intercept. And once again, you can clearly see that the overlapping or checkerboard area here contains all of my solutions, and this goes on for infinity. Okay, a lot of times this question tends to stump students. Don't sweat it. Remember that a y equals equation, when it has no x's, is literally a horizontal line. So I'm literally going to go 1, 2, 3, 4, 5, and y is less than or equal to 5 is a horizontal solid line going through the 5, and y is less than or equal, so I'm shading below. And then for my x is greater than -3, an x equals equation with no y's attached to it, that's going to render you a vertical line. So I'm going to go over to 1, 2, 3 over here, and it is a vertical dashed line because it is greater than, not greater than or equal to, and x is greater than -3, so you are going to shade to the right, and then immediately, once again, you should recognize your awesome checkerboard patterns here, and these are the solutions. All right, so I hope that helps out. I hope that makes it very easy. All right, let's get to some word problems now. All right, your city's cultural center is sponsoring a concert to raise at least $3,000 for the city's youth services. Tickets are $20 for balcony seats and $30 for orchestra seats. If the center has 500 seats in total, find 3 combinations of orchestra and balcony seat sales which will earn at least $3,000. Okay, so we have 2 different things going on here. For systems, when we're dealing with word problems, I always, me personally, like to think of each equation as a quantity and then a value. Quantity being a count, a number, 7 tickets, 12 baskets, quantity. And then a value is a monetary value or a percent value. It's 30% or $500. So think of quantity as a counting value, a counting amount rather, and value the actual value of it, what it's worth. So as far as quantity here, if you read carefully, it does state that the center has 500 seats in total. Okay, and these seats are made up of orchestra and of balcony seats. So first things first, me personally, I'm going to go ahead and call X my orchestra seats, and I'm going to call Y my balcony seats. And now my quantity, I know that the amount of orchestra seats plus balcony seats has to be less than or equal to 500 because that is the seat capacity that they have. And my value, I know that it's $20 for every balcony seat and $30 for every orchestra seat. So $30 for every X orchestra seat plus $20 for every Y balcony seat must be greater than or equal to $3,000 in order for the cultural center to actually raise the money that they're looking for. So now, I'm going to give you a little hint, a little trick here for word problems when dealing with inequalities. Me personally, I will not solve for y and then graph the y-intercept and follow the slope. It's going to get quite nasty when you do that in real life. Now on a calculator it's nice and easy, but let's say you have to do it by hand. How do we do this? Use x and y intercepts. Remember that you can find an x-intercept by making y 0 and finding the value of x. You can find the y-intercept by making x 0 and finding the value of y. So let's go ahead and use our equations here and find the x and y intercepts of each different equation that we set up, both the quantity and the value. So first off, let me go ahead and make a little graph here. And I'm going to go by, let's say by 50s. So 100, 200, 300, 500, 500. Okay. We're going to do the same thing on the y value as well. Making your intervals is very important. I know that it takes a little bit of time, but it's definitely worth it because it makes your life a lot easier. Okay? And always label your graph as well. Let's go ahead and call this horizontal the X. This is my orchestra seats. And my Y are going to be describing my balcony seats. Okay, so first things first, let's find the X and Y intercept for the quantity equation. When Y is 0, the X-intercept is 500. I can have a max of 500 orchestra seats if I don't have any balcony. And if I have 0 orchestra seats, I can have 500 balconies. Now, the value. The X-intercept of the value equation, when I make Y 0, 3,000 divided by 30, is 100. And for the Y-intercept, when I make X 0 and solve for Y, I'm at 150. So for my first quantity equation, let's go ahead and connect those dots, and this is less than or equal to, so it's below. And then for my value equation, this is greater than or equal to, so this section here in between denotes my possible solutions that will render the amount of money that I need. And let's go ahead and find 3 combinations because that is what they ask for. So we can have, for example, 200 orchestra. Let me put this in purple actually. This point right here. We can have 200 orchestra seats and 300 balcony. Perfection. How about this combo right here? We could also have 50 orchestra and 250 balconies. Or let's say this point right here. We could also sell 250 orchestra seats and 100 balcony. And all of these combinations will give the center at least $3,000 of earnings. And that's how that works. Check out another one. Samantha can invest up to $50,000. Her financial advisor suggested that she place at least $10,000 in treasury notes and no more than $35,000 in corporate bonds. Write a system of linear inequalities that models this situation. Well, let's go ahead and first label. Me personally, I'm going to go ahead and label C for corporate bonds. I'm going to label T for treasury notes. And there you have it. Now, let's see what we have. Let's think of quantity and let's think of value. So we know that Samantha can invest up to $50,000. So as far as quantity goes, the amount that she invests in corporate bonds plus the amount she invests in treasury notes must be less than or equal to 50. We also know that she is to place no more than $35,000 in corporate bonds, so we want the corporate bonds to be less than or equal to 35. And she was recommended that she at least place $10,000 in treasuries. So this right here is the system that we're dealing with. That is A. Now let's look at B. Please don't stress out. Remember to use your intercepts, and also remember the power of vertical lines and horizontal lines. For example, in this particular case, let's go ahead and copy that, paste it over here. Okay, so in our particular situation here, let's go ahead. And let's go ahead and go by fives. So this would be 10, 20, 30, 40, 50. And we called C the corporate bonds, so we're going to call this corporate bonds. And then we're going to go ahead and do the same thing on the y-axis. We're going to go by 5, so 10, 20, 30, 40, 50. And that is going to be my treasury notes. Okay, so C plus T is less than or equal to 50. So when my treasury notes are 0, my corporate bonds have to be less than or equal to 50,000. When my corporate bonds are 0, my treasury notes have to be less than or equal to 50,000. We connect those dots using intercepts, and that is less than or equal to, so that will be shaded below. We do know that the corporate bonds, though, must be less than or equal to 35,000. So that means we have a vertical line, going through 35,000 here. And it's going to be less than or equal to. So that means it's everything to the left of it. So far you can see a little checkerboard being created. And then last but not least, we know that treasuries have to be greater than or equal to 10. So over here we have a horizontal line, and that's greater than or equal to 10. So once again we shade up, and now if you can see where all three shadings occur, that's my solution right in here. Okay, so now we can start answering questions. Can Samantha place $20,000 in corporate bonds and 30 in treasury? Well, let's look at our solution set here. If we go 20, 30, that's this point right here. That's in the solution set. So that's yes. Now, how about, can Samantha place 40,000 in corporate bonds and 10,000 in treasury? Well, that will put us over here. And that is outside of that solution set. Because remember, corporate bonds have to be less than or equal to 35,000. So that would be no. And that is the power of solving systems of linear inequalities. Thank you so very much. Hope you learned a lot. Have a great day. Come back anytime now. Bye-bye.